I don't know if you know about this, but there is this thing called a solar eclipse, and on April 8th, and it's kind of a big deal, but it might be cloudy. But nonetheless, there's a really cool physics problem that goes along with it, and I got this card, punch card. I got this at, I think I got it at AAPT, and I'll put a link to this website down below. But it has a circular hole, so you can make a pinhole of the sun while it's being partially eclipsed, and you can see what it looks like. But then look at that. There's a square hole and there's a triangular hole. And what happens when you use the triangular and the square hole? It depends. The answer is it depends. If you're far from the projection screen, you still get the image of the sun. So let's model this. Let's see how this works. Okay, so I have a video for you. Here is a video that I made. This is another example. So here is a tubular light. So my light source is not a point source, right? Because if you have a circular source and a circular hole, you get a circle and no one's surprised. But if you have a line, what if I have a line source? I can't remember what the source. There's my line source.
Here is a
And I don't want to hear that.
So it's a line light.
Turn that off. Okay, and there's my triangular hole. Now I'm going to look at the image. There you see the image right there. There's that line. That's the line source. If I have a triangular hole with a line source, I get a line, which is pretty nice. But if I get really close to the screen, you can see that image changes into a triangle. So really the answer is that when you have two shapes, a light source shape and a hole shape, you get both, right? When you're really close to the hole, you get a triangle made up of a bunch of squiggly lines. When you're very far from the hole, you get a line made up of a bunch of triangles. And I want to model that. So let's just go ahead and model that. Let me switch over here to the paper because we're going to start off doing some animations in Web VPython, or at least visualize it. Okay, so imagine that I have a simple case, a single hole. Okay, what if I have, here's my hole right there, and then here I have a screen. And now imagine that I have a red light right here. Well, there's only one way for that light to get to the screen. It's going to be like this. And so I'm going to get a red spot on the screen. Now imagine that I have a green light. See, I'm using colors. It also can only go through one. This is a tiny hole. And I get a green spot, right? So I want to be able to make these. But now what if I have something that's bigger than a single hole? Well, one way I could model a square hole like that is by a bunch of super tiny holes. So each green light is going to have to go through each of these green holes. Each red light is going to have to go through each of these holes, and we can see what pattern we get on there. And I want to visualize this in Web VPython. Okay, so in general, how do I make a point source? I'm going to make my point sources. I'm going to make my holes. So I'm going to have sources. I'm going to have holes. And then I'm going to get images. And you can see, imagine that if I want a line source, I can put a whole bunch of sources with a whole bunch of holes with a whole bunch of images, and it can get a little out of control. So we're just going to start with just two sources, have a whole of, I don't know, 25 circles for my square, and then we can see what we get over there. It'll be really cool. But now what we really need to do, this is going to be have some vector location. I'll call that RS. And this is going to have a vector location R hole. Now how do I find that? Right, because that's what I want to do. Those holes can move around. Well, the first thing I'm going to do is define this vector. I'll call that RSH. That's the vector from the source to the hole. Now I need this D. What am I calling this? DHS. That's this distance from the hole to the screen. And I'm going to cheat here. Okay. So now if I take a unit vector of that, if I take that unit vector and I multiply it by this, I get this vector. All right, so I can then find out where it ends up. So I'm gonna take this, I'm gonna do it simple. I'm gonna make 2 point sources and a hole, and then I'm going to draw these two lines, and then I'm going to change that to a bunch of holes. And then we'll do it more complicated. So this is complicated stuff, and it may take a while, but I'm here for the long haul. Okay, let's just jump over to Web VPython and start doing some stuff and making a mess. That's what we're going to do. I've already put in some values here, so just because I had to visualize it. So RS is the size of my source. So I have three things: sources, holes, and images. So this is the size of my source. That's how far apart they are. DS is the distance from the source to the hole, and then DHS, which I know it's dumb, is the distance from the hole to the screen. And then LH is going to be the width of my hole. So let's just make 2 point sources. I'm going to make them spheres, and I'm going to call this RS for the red source. It's just a sphere. Its position is going to be equal to, I'm going to put my screen, how do I want to do this? I want to put my screen at the x equals 0. Yeah, let's put the screen at x equals 0, and then, so this will be in the negative x direction. So this is going to be, let's say, vector negative ds, and then I want to move it up in the y direction. So that's going to be rs over 2, just to be clear, 0. Now, how big is that going to be? How big did I make it before? I'm checking over here how big I made it. I made it LH over 7. And this is going to be color equals color dot red. Let's just run it. 1 dot, no big deal. And it didn't do it. Why isn't my color red? Position equals L radius. That's why. Okay, so there's my dot. Okay, now let's make our hole. Hole is going to be a sphere. It's just going. Do I even want to draw it? Yeah. 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 I think so. So it's going to be position vector 0, 0, 0. It's at the origin. Radius is going to be the same. LH over 7. 7, and that's fine. Now I want to find the location of the image. So the first thing I'm going to do is to say, what did I call that? RSH equals the hole position, which is hole.pos, minus the image position, rs.pos. Now I can find the location of the image. It's going to be, let's call this spot, r spot, and we're going to change it later. R spot equals a sphere. Position is going to be equal to norm RSH times DHS plus hole.pos. Right, so I'm going to start from the location of the hole. I'm going to add on that screen. I didn't tell you how I was cheating. I was cheating because I'm not going to have a flat screen. It's going to be curved, right? Because they're all going to be the same distance from that screen. But if it's far enough away, it shouldn't matter too much. And then let's give this a radius of LH over 7 and a color dot red. Let's see what happens. Okay, so there, that worked. There's my source. There's my hole. There's my image. And now let's add a line. So I'm not even gonna give it a name. Cylinder POS equals rs.pos. Axis equals rspot.pos minus rs.pos. So that's going to be my location. And then the color.red. Oh, I need the radius. Radius equals LH over 15. There we go. So there's my image and my screen. Okay. So now I could I could add another source. Let's just do 2 sources. So I'm going to repeat over here, copy this, 1 hole. Copy that, but call it green source, so GR. And it's going to be negative. It's going to be below there, and it's going to be green. And then I need to calculate GSH is hole.pos minus gs.pos. And then I need a G spot, sphere, same thing. Position equals norm GSH times DHS plus hole.pos. And this is the same thing. Radius equals LH over 7. Color equals color.green. And then finally, I need another cylinder, so let's just copy this and post it right there. This is going to be GS. This is G spot. The G stands for green. GS. And this is going to be green. Okay, 2 spots. Awesome. So now all I need to do is to make my square hole, right? And then I can go through and do this same thing for all the square holes. So let's make our square hole. I haven't saved this. Okay, so this GS, I'm just going to make the 2 holes. I want to make hole. I'm going to get rid of this. Let's get rid of this. Let's just comment it out. And I'm going to get rid of this because I haven't done that yet. And then all this stuff. Let's just get rid of all this stuff. There. And I'm going to put this right here. So my 2 sources are together. And I just commented out because I might need that, and so I don't want to do that. Let's do this. NH equals 5. I want it 5 by 5. I'm going to make a 5 by 5 hole. N equals 0. Actually, no, I don't need to do that. So what I'm going to do is to, now I need my I'm going to start with a hole. Let me switch over to the paper real quick so we can see what's going to happen. I'm going to start right here, my R start, and then I'm going to add into the X direction, until I get to here. So this is R start X, R start Y. And then I'm going to move down and reset my X value and move over this way. So I'm going to go vert, 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 vert. I'm not going to make that noise, but that's the idea. Okay, so let's make an R, a DS. A DS is my step size. DS equals NH, which is the number of holes sideways. I'm sorry, it's going to be LH divided by NH. Yeah. And our start is the upper left-hand corner. It's going to be equal to the vector negative LH over 2. LH over 2, because I want the square centered on the origin, 0. Now, I'm going to make a hole, and I'm going to add it to a list of holes. I don't want to just print them all out. So I'm going to actually make holes as an empty list that I can add stuff to. Okay. While rstart, I don't know why I called it rstart. rstart.y is greater than or greater than negative. I want to go in the y direction, so I'm going to go down to the y direction. So as long as it's greater than negative LH over 2. And then I'm going to reset my x, rstart.x equals 0. No, negative LH over 2. And then I'm going to go across in the x direction. So while rstart.x is less than LH over 2. Okay, so now I'm going to do that's a double loop, right? So I'm going to add that value of rstart to the hole. So hole equals hole plus rstart. It's a vector. It's a 3D vector. Now I'm going to move my x value over. So rstart equals rstart plus the vector ds 0, 0. Now, once I get done with that loop, I need to move my y down. So rstart equals rstart plus vector 0, negative ds 0. So it's going to move it down. And we should have a bunch of holes. Okay, we can put a sphere there too if you want. I can put a sphere just so we can see what it looks like. Sphere position equals rstart, radius equals what was I saying? LH over 7. Yeah. Okay, let's see. I'm a little scared. because sometimes things mess up. Yeah, I see something messed up. Hole. Did I call it holes? Yeah, I called it holes. That's why. Holes. Holes. Okay. So there they are. Now I did make a mistake, right? I put this in the XY plane. I want to put it in the XZ plane so that it can go that way. So we can fix that. Easy to fix. So instead of Y, I'm going to go in the Z direction. Yeah. And so this is going to be, that's fine. R start, that's fine. And this is going to be 0. Okay, let's see if that works. Yeah. No, did not work. Oh, I just typo. Typos are fine. This is going to be a long video, just warning you. I'm already at 16 minutes. I'm not even at the second program. What did it say? R start. Oh, Z. That's not right. What the heck happened there? While R start, that's why. Three dimensions are complicated. No, it's still not working. That's in the, I want it in the YZ plane. That's what I want. No one needs to stop me. So let's put this back to Y. Put the 0. That's YZ plane. So Z goes from that. Y will go, we'll put Y go from that. And then this is going to be Y. And then that's fine. That's fine. And this is going to be in the Y direction. I think I'm going to mess up something bad here. Okay, let's see if that works. I'm just trying to make a bunch of holes. Did it. Okay, there's my bunch of holes. I don't even need to display those, right? But those are my holes. Okay, so now I have the holes. Now for each hole, I need to redo the same thing for both the red and the green. So let's do this. I don't even want to display, I do want to display those, but I want them much tinier. Okay, 17. For hole in holes. Now remember, holes is just a list of vectors, right? They're not actual objects, so I don't even need to worry about, let's call it actually RH for our hole. RH in hole. So the first thing I'm going to do is same thing down here. I'm going to calculate this. So RSH equals RH minus rs.pos. That's the same thing I did right there. And let's do the G too. The GSH equals RH minus gs.pos. So now I have those two vectors. Now I can make the spots. Do I want to even add it to the image? Let's just make this. Let's just make it a sphere. I don't even really, no, I do need a spot. And I can change it, I guess. Let's call it a vector. R spot, just the vector part. So I'm going to use this. Norm RSH, it should be the same thing, times DHS plus RH. So instead of hole.pos, I just have RH, the position of the hole. And then G spot is going to be norm GSH times DHS plus RH. So now I have the vector locations of those two. I can put a sphere there if I want, and I will. Let's just do that. Sphere position equals R spot. Radius equals LH over 7. Color equals color.red. And then the same thing. Sphere position equals G spot. Radius equals LH over 7. Color equals color.green. Okay. Now, I'm going to draw the axis. So the same thing I did right here, the cylinder. I'm going to copy this actually. Let's just copy that. See if I can copy that and post it right there. Okay, so I'm going to put a cylinder. Its position is going to be not rs.pos, but rspot. That's the location. The axis is going to be rspot, which is just a vector, minus rs.pos. That's fine. That's good. And then the same thing for the g. G. And this would be G. Is that right? Yeah. GS, that's the image. Okay. Color green. Okay. Let's see if this works. Kind of worried. Okay, so we got something here. But I don't have... Oh, that looks cool. Okay, so I think I messed up my location of these cylinders. The position is not rspot, it should be rs and gs. Let's see if that did it. Which are objects, so this should be .pos. Okay, run it again. Boom. Boom! Look at that. That's pretty cool. So there is my red passing through the square hole and it makes a square spot, and my green passing through the hole and it makes a green spot. And you can see that they kind of overlap a little bit, which is cool. If I get really close, you can see those two would not be overlapping. And if I get really close to the screen, they should be completely overlapping. Let's see if we can just change that. Shouldn't be too hard. Let's just move the screen further away. So this is the hole to screen distance. Let's make this 0.6. See what happens. Okay, so things are getting a little big, but you see here, now my images are not overlapping. And let's make it really small, 0.5. And now they do overlap. So this is the key here, right? I'm getting square images because there's a square hole. But if it's really close, I'm getting them overlapping, and I get a square. If they're really far apart, I get two spots made of squares, and which is what I said. Okay. Now we need to make a better program and not in VPython. And normally I would work through this, but I'm going to instead just show you because it takes a little bit of time to make. But we're going to use the same idea. So I'm just going to show you this code, and then we can have fun with it. And I'll give you a link to both codes below. And I know you guys like me to work through stuff, but it's just going to take too long. And the thing is, I'm going to make a mistake. I'm pretty happy with that, though. So I'm going to give you that code, and I'm going to give you this next code right here, which is right here. Okay, let me run it, and then I'll walk you through what's going on. Is that pretty? Okay, let me run that again. Let me make that a little bit smaller so you can see the whole thing. So this is a circular source passing through a triangular hole. And what happens is I move the screen further and further away, and we see what's on the screen. So it starts off as technically a triangle made up of circles, and then it turns into a circle made of triangles. And that's pretty cool, right? That's pretty cool. Okay, so here's how we do this. So first of all, I was going to make 3 graphs, but I only need 1 graph. And it's an animated graph, but that makes it complicated. So this is the, which is the one that I'm using? Let's see. I'll make this bigger. And this is a little bit sloppy, I get that. F3. I'm just using graph 3. Okay. So graph 3 is the image. Okay. So I have the same stuff. This is the radius of the source, the distance from the source to the screen, the distance from the hole to the screen, and then that's the width of my square hole, and I'm using a triangle. But you can change this to whatever you want. Now I have 3 lists, right? Because I have a list for all of my objects in my source because I need to make that. I need my list for my objects in my hole, and then I'm going to generate my list for my objects in the image. So they're all lists. Don't worry about that. I originally had a square hole. I cut that out. And then here's a triangular hole. So the triangular hole, you start up here, you start at the top, and then you go over 1, and then you go across, and you go over 2, and you go across, and so forth. It's like that. And so it does indeed make a nice triangular hole. And this will make, this NH tells you how many step sizes are. So you can change the size of your square hole. Your triangular hole. So just like before, I have an empty list hole, and I go through, this looks a lot like what we use to make the square hole, right? But here I start at the top, LH over 2, and then I just go until I get down to negative LH over 2. I'm in the XY plane now, just because it's easier. And then the X start has this negative NS, right, where N starts at 0. So I start with 0, and the next time I go over 1/2, and then I go over 2 halves, and then over 3 halves, and so forth. And it does make a nice triangle. It's really kind of fun. Okay, ignore all that stuff. Now I need to make my circle. I just made a line of a circle. You could fill it in if you wanted to. I just made a line. I want to have as few points as possible. So to do that, I just have my theta value, and I increase the value of theta and move around in the circle, and I put a point there, and I add that to my source list. So now I made my triangle, and I made my list. And now we're just going to do the same thing we did before. But I need to move my screen size. So I'm going to have a loop inside of a loop. So that's where this rate comes in and this DHS. So I'm going to move it until my source, my screen, is 0.1 meters away. So I'm going to start off with it 1 millimeter away. I'm going to move to 10 centimeters away. So that's how I'm going to move. So I need to, every time I restart, every time I move my screen, I need to clear my image, and I need to clear this F3 data, which I'm using for graphing. Okay, so to make an animated graph. Now this is the part where I go through just like before. In the hole, I need to go through all my sources, so I have a double for loop. So for RT in hole and for RS in source, right? So it's a double for, and that's why you can see if you start having a ton of points, you're going to get a ton of calculations here. It's going to blow up fast. But again, I find that R hat vector, I use that to find the location of the image on the screen, and then I add it to the list, and that's all that does. And then I need to move my screen, and then I go through here. This makes the animated graph. So to make the animated graph, I want to plot their X. I'm actually plotting their XY coordinate, right? Because this is in the Z direction. And so I add a data point to the list. I go through, and then I graph that. And so up here you have to clear the graph, and there you go. So let's run it again and see what happens. So there you go. And you'll notice it starts off, let's just put this at rate of 1, really slow. It looks like, it looks like a blob, but that's actually a triangle made out of a circle. Did you see that? Let's run it again. It's a triangle made out of a circle. Right there. See, it's just very rounded edges because I don't have that many points in my triangle. If you increase the number of points in your triangle, then you should get a better thing. Let's just try that. Let's try increasing the number of points in my triangle, which is up here, triangle. Let's just try 10. It may not work. Okay. A little bit, and so you get this. See that little thing? Just because the way I counted, I made a triangle with a little bump on the end. It's fine. But it's kind of cool. Okay, so there you go. Complicated sources passing through complicated holes to make complicated images. Have fun at the solar eclipse. Hopefully it's not cloudy. Links to both these codes down below. The end.